Hello, and welcome to this tutorial on building a home lab for Zeek and ELK Stack for SOC Analyst training. This guide will provide a step-by-step tutorial for setting up a home lab using Zeek and the ELK Stack. I say the ELK Stack because that's what comes to mind when you think of Elasticsearch and Kibana, but instead of Logstash, we will be using the Filebeat module, which is sort of a lightweight module, and it's a lot more simple to set up, and sort of we can ignore a lot of the complexities that come with Logstash when doing this. So this lab is designed to help you gain hands-on experience in network security monitoring and log analysis. And sort of if you were a SOC analyst, this is what your day-to-day life would look like. Just working with security logs, trying to make sense of all the telemetry that's ingested. Once we sort of set up the SOC and we're able to sort of monitor our home network, we're going to move on to sort of using some sample logs, so actually simulating malicious traffic and just analyzing those logs and seeing what it would look like in the real world. So thank you for watching, and let's jump right into it. Thank you. So I have sort of a very high level and rough network diagram over here of this lab. So as you can see, we have a router that's connected to the internet, and then my desktop, which has this network interface card, which is basically it's a wireless network interface card. It's how I get access to Wi-Fi, and the interface that we will be monitoring specifically on this desktop, or how it is in our VMware hypervisor, it's called ENS33. And once we dive into the lab a little bit, you'll sort of see that. So that's the primary interface that we will be monitoring to start off with. And there's a bunch of other home devices that are also connected to the router and to the internet. And once we start looking at the the logs and looking at the network traffic, we will sort of see DHCP and DNS requests on this interface. So you can sort of see how these devices also communicate with other devices in the environment, even though we're not explicitly doing like sort of a network tap monitoring. Like we're not monitoring all the traffic that's going onto the router, just what's going, just the traffic from the desktop onto the Wi-Fi, but we will still see in the logs certain host names that would be from these devices. So it will be quite noisy, where we'll see traffic that's not directly from the desktop, but once we get into it, we will sort of in our hypervisor. I'm using VMware Workstation Pro. Feel free to use any other hypervisor of your choice. We will be using Ubuntu desktop, and on this Ubuntu desktop, we will be running Zeek and Elasticsearch, Kibana, and Filebeat. Ideally, you could have two separate virtual machines where you have Zeek running on one virtual machine and then shipping out logs to the other one. But for the sake of this lab, we're gonna do both of this on a single VM. And yeah, so this is sort of a high-level overview of what it all looks like, and let's start with the lab. Thank you. So the very first thing that we want to do is obviously go ahead and download our hypervisor. I already have it installed. As you can see, I have a VMware Workstation, and we're going to go ahead and create a new virtual machine. So let's go ahead and get our Ubuntu desktop image. Go on next. We're going to quickly create our credentials. So let's go ahead and do that. And we're going to name this virtual machine Zeek Lab. We're going to give it a disk size of 100 GB. The minimum specs for this lab are about 50 gigs. So if you do not have 100 GB of free disk space, at least try to have 50. And we're going to store virtual disk as a single file. And for our network adapter, we're going to use Bridge. Let's go ahead and boot this up. Oh, and also, while we're at it, let's go ahead and give it 4 processors, and we're going to bump the memory up to 8 gigs. The minimum specs are 2 processors and 4 gigs. So again, if you do not have a very powerful system with enough RAM and processors and memory to allocate, those are the minimum specs, and I will be sharing a document with all of the minimum specifications and requirements. So let's go ahead and do that. We're going to use a wired connection. We're going to skip the update. You don't have to install third-party software for graphics and Wi-Fi hardware and the rest, but since I'm not using an actual wired connection, I'm using Wi-Fi, just to avoid any compatibility issues, I'm going to go ahead and check that. And let's go ahead and create our account. So we're going to call it student. We're going to call the computer Zeek Lab and keep student as our username. Set default credentials here, since it's just a lab. If you're doing this in an actual enterprise environment, I would highly suggest a strong password, and please avoid default credentials in an actual deployment. So once the install is complete, we're going to go ahead and restart our system. Let's go ahead and log in with the credentials we set during setup, and let's jump into the terminal. So the very first thing we want to do is sudo apt update. And once that is done, we're going to go ahead and set a static IP address, since it's configured currently to use DHCP. And the reason we don't want that is just for stability purposes, where since we're going to, as you're going to see in the lab, we're going to assign specific IP addresses, and given DHCP's nature, we don't want it to change and cause our whole lab to break. So let's go ahead and take a look at our interfaces. So to do that, we're gonna have to go ahead and type in IPA. And as you can see, we have our loopback address here, our loopback interface, and then our actual interface here, which is ENS33. The IP address assigned by DHCP here is here, as you can see, and we want to change it to static. So we're gonna go ahead and create our netplan configuration file. I would ideally use Vim, but for some reason on VMware Workstation, on this VM, Vim does not want to work the way it usually works. So please don't judge me. I'm going to go ahead and use nano edc netplan 01.config.yaml, and we want to go ahead and type in the following: network, our actual interface, and we want to type in DHCP4 as no, DHCP6, set it as no, and type in the actual static IP that we want to set. We're going to use default routes, so routes to default via our gateway. And for our name servers, we don't want to use any. And for the addresses, let's just use Cloudflare's DNS. Keeps tabbing me out for some reason, right? And version 2. So let's go ahead and save that. And before we go ahead and apply the net plan, we also want to go ahead and disable the current DHCP. So we can open the cloud init YAML and then change this to false. Once that's done, we go ahead and type in sudo netplan apply. Okay, the permissions are too open. In that case, we're going to go ahead and change this to change the permissions, right? So make it less open. Netplan should not be accessible by others. So sudo chmod 600, and let's type in netplan. And now when we go ahead and apply the netplan, we should not get any issues or errors. Let's verify our new configuration. Type in IPA again. As you can see, the IP address has been changed, and let's take a look at our IP route. See the default route has been set, and we're just going to verify that we can communicate to the internet. So I'm going to go ahead and ping our DNS server, and you can see it is working. So we're good to go, but prior to this, I'm just going to go ahead and reboot our system just to be on the safe side. So now let's go ahead and install Zeek. So you want to navigate to Zeek's official page. In Google, you can just go ahead and type in install Zeek and click on the second link here about get Zeek. Or if you want to take a look at the actual documentation, click on the first link and go through this. So we're going to go ahead and install from the binary. You can go ahead and download the actual source code and build it from source. But for ease and convenience, we're going to use the recommended approach, which is using Linux binary packages. So given your operating system, go ahead and follow the steps. We're using Ubuntu 24.0.4, so we're going to go ahead and run the following. We don't have curl installed, so we're going to go ahead and install curl. Okay, once that is done, we're going to go ahead and run the commands as per Zeek's documentation. And we just have to do sudo apt update and then install. So sudo apt update. And just to make sure, okay, sudo apt install Zeek, and we want the latest version, which is 7.0.5, but go ahead and type in 7.0, and it should pull the latest build. Once the Zeek install is done, this step is important, where we want to add Zeek to the user path. This ensures that Zeek commands are accessible from any terminal session, and this is important because right now, if you try to verify if Zeek is installed, it's not going to return anything. You want to check the Zeek version. It's not going to return anything unless you specify the path it has been installed in. So to avoid having to type in the path every time, we're going to go ahead and add it to our user path. So to do that, we're going to type in echo export path and the path where Zeek is installed, add it to our path, and then -rc, and then we're going to go ahead and source -rc. Now, when we go ahead and type in which Zeek, there you can see the directory, and we want to check the version. You can see the latest version, 7.0.5 is installed. Now, to configure packet capture from our interface, we want to identify the network interface we want to packet capture from, and as previously shown, it is ENS33. So we're going to go ahead and modify the Zeek configuration. So let's do sudo nano opt zeek etc node.config, and we're going to go ahead and change our interface over here from ETH0 to ENS33. That's all. Go ahead, exit and save. And now we're going to go ahead, enable and start Zeek. So sudo. Now you can go ahead and, since we've not added Zeek CTL to our path, we have to specify the path. And for some reason, it's a little more complicated than just adding Zeek to the user path when it comes to Zeek control. I'm not too sure why, but we just have to run this command once. So we're going to go ahead and specify the full path for Zeek CTL. Zeek CTL deploy. And there you go. Zeek is up and running. We can verify that by just checking the status. There you can see the name Zeek, type, host, status, the process ID, and when it was started. And also to make sure our scripts are, or well, the default scripts are all fine and running, we can just go ahead and type in check, and it will say that Zeek scripts are okay. So if you make any modifications or customize scripts and you want to make sure that they sort of are not misconfigured, you want to always go ahead and check before you run Zeek. Now, let's see if Zeek is actually producing any logs. So the directory where logs are sort of created and stored is opt zeek logs sudo current. So let's just jump into root and check that. As you can see, we have capture logs, connection logs, DNS, loaded scripts, notice, packet filter, stats, standard error, standard output, telemetry log, and there should be some more loading up. Okay, I don't see that yet, but there should be another log file called weird.log, which basically it logs anything Zeek deems as anomalous. And yeah, so let's go ahead and take a look at connection logs. So you want to type in tail-f at connection logs. There you can see the fields and the type of the fields, and here you can see the actual fields. So we have the timestamp, the UID, the ID origin, the host source IP, the originating port, and yeah. So Zeek is creating logs, and we're able to see them. So that's good. Now let's go ahead and install and configure Elasticsearch and Filebeat. So let's go ahead and install Elasticsearch. Similarly to how we install Zeek, we're going to go on Google and type in install Elasticsearch. Since we are using Ubuntu, we're going to go ahead and install Elasticsearch with Debian package. So the steps are quite similar and very straightforward, where we're going to go ahead and import the Elasticsearch PGP key and install from the apt repository. So let's go ahead and exit out of root and ensure we have wget installed. We do. So type in sudo wget. It might just be easier to copy. So we go ahead, copy that command, and type in sudo and drop it in there. So that is done. We need to install the apt transport HTTPS package before going forward. So let's go ahead and do that. And once that is done, I'm going to go ahead and save the repo definition to apt sources list.d elastic 8.x list. So let's go ahead and do that. And once that is done, we're gonna go ahead and install the Elasticsearch packet. So sudo apt get update sudo apt get install Elasticsearch. Once the install is done, we're going to go ahead and make this quick change to the Elasticsearch config file. So let's go ahead and open up elasticsearch.yaml. And what we want to do here is set our bind address to 0.0.0, so any host on the network can access Elasticsearch. This is not recommended in a production environment, as it's not quite secure for any host to access it, but for the sake of this lab, we're going to go ahead and uncomment network.host and set this to 0.0.0. And we also want to go ahead and uncomment our HTTP port here. Once that is done, you want to save the file, exit out of it, and start the Elasticsearch service. So I'm going to go ahead and type in sudo system control start Elasticsearch. And once that is done, we're going to go ahead and enable Elasticsearch. So every time we boot the system up, Elasticsearch starts automatically. And let's check the status. There we go. We can see it is loaded, enabled, and active. Now, once that is done, we want to go ahead and reset the credentials and take note of the credentials. So that way we can log on to our Elasticsearch instance. Usually in previous versions of Elasticsearch, there would sort of be an interactive install where you could set the credentials prior to installing everything, but since it has been updated, it automatically sets the credentials, and there's a way to go in and find the credentials, but it's just much more simpler to go ahead and reset the credentials. So let's go ahead and type in sudo share Elasticsearch bin, set up passwords, interactive. Oh, sorry, we want to reset the password and want to reset the password for the Elastic user, which is the default username that's assigned. So once that is done, it should output the password to the console. So we want to go ahead and note that down. So I'm going to go ahead and copy and sort of in our home student directory, we go ahead and create a text file called Elastic Credentials. Go ahead and paste that. Just to make it a bit simpler, we're going to call says user Elastic. There we go. I'm going to save this file, write it, exit out, and now we're going to go ahead and verify that Elasticsearch is actually running. Again, in the latest version of Elasticsearch, it is configured by default to use SSL and use HTTPS. So if we're going to try and use HTTP, it's probably going to return nothing. So let's go ahead and try that. We're just going to go ahead and curl using HTTP. So you want to type in your user, colon your password, and HTTP. As you can see, there is an empty reply from the server. So what we want to do here is HTTPS, and now you can see we have our name as Zeek Lab, the cluster name, the version, and yep, it is up and running. Now the next step is to go ahead and install Kibana. So pretty straightforward. Type in sudo apt install Kibana. Once it is installed, similar to how we set the bind address in our Elasticsearch config file, we're going to do the same thing for Kibana. So let's go ahead and update the Kibana config file. In order to do this, we're going to have to go back into root. And as you can see, I struggled to sort of do that previously, and I realized I was using the wrong file name the whole time. So make sure you don't do that. It is the file name, the config file name is kibana.yml, and it is located in the etc/kibana directory. So we're gonna go ahead and edit that file. Go ahead, nano, etc kibana.yml. Now we want to go ahead and find in server.name. So quickly, sorry, server.host. There we go. We change it from localhost to bind the address to 0.0.0. So change that to 0.0. And I think we do need to uncomment this as well, but for now, I'm just going to leave it as it is. Let's exit out of here, save the file, and the next step is to go ahead and start Kibana. So we're going to exit out of root and type in sudo systemctl start Kibana. Once that is done, similar to how we enabled Elasticsearch, we're going to go ahead and Kibana. Now let's go ahead and take a look at the status. Here we can see it is enabled, active and running, and it is telling us to go to the bind address that we set, and this is the URL. So I'm going to go ahead and copy this link. And the whole reason I use Ubuntu desktop and not Ubuntu server is so that we have access to the browser on the virtual machine itself to go ahead and access it. I mean, since we're on our desktop through this virtual machine, we could still access it from our desktop here, as you'll see. Was to type in 0.0.0 port 5601. It would still take us to, let's just do 1, 2, 1, 6. It would still take us to the Elasticsearch UI, but just to keep everything on one machine and do everything on one machine for the lab, we're going to use Firefox on the virtual machine itself. We're going to go ahead and paste that over there. And as you can see, it's asking us to paste the enrollment token. Now, how do we find it? You need to generate a new enrollment token and run the following command from the Elasticsearch installation directory. So remember where we ran reset password from? That's the exact same directory where we can create the enrollment token from. So go ahead, scroll all the way up to, yep, so it's a user share Elasticsearch bin, and over here we need to type in Elasticsearch create enrollment token, and we don't need to specify the scope, or actually I think we do, so we're going to type in scope, Kibana. Give it a second while it generates the token. Here we go. Now that we have this token, we're going to go ahead and copy it and go ahead and modify the Elasticsearch text file that we had previously created. Oh, I did not mean to. Did we just overwrite? Oh, that's not good. Okay, we did not overwrite anything. Yep, so we're going to go ahead and paste our token here. Now once that is done, I'm going to go ahead and update the file and also paste the token here. As you can see, it resolves to our server host with the 9200 port for Elasticsearch. Go ahead and click on configure. I'm going to save the settings, start Elasticsearch, and complete the setup. Now we can log in with the credentials that we had previously set here. Go ahead, copy that and paste it here, log in, and let's save it. Why not? And now we can add integrations. So what we want to do here is download and install Filebeat. So we go click on add integrations and search for integrations. You want to type in Zeek. And bottom right, you'll see also available in Beats. And that's what we want. So we can go ahead and click that and then follow the steps per your operating system. So we Linux Debian and follow these steps here. Go ahead and paste that, run it. It's going to download Filebeat, and then after that, it's going to go ahead and install it. Here you go, it's done, and now we're going to have to modify, similarly to how we modified Elasticsearch and the Kibana config file, we're going to have to modify the filebeat.yml file and set the connection information. So we're going to have to put in our server host, username, password, and we will also have to grab Elasticsearch default certificate, the fingerprint, and paste that in here, and then our Kibana host. So let's go ahead and first, let's go ahead and find Elasticsearch default certificate. So how do we do that? So we're gonna have to go ahead and find where it is. It's usually in the etc Elasticsearch search directory, but let's just use the find command to get the exact location or the storage. So we're gonna type in etc Elasticsearch. There we go. It is in the etc Elasticsearch search directory. So let's go ahead and cat. So let's go ahead and navigate to that directory. Sudo over here. Sorry, we have to go into root, and as you can see, we have http:/ca.cert, http.p12, and transport.p12. We the fingerprint here, so we're gonna go ahead and type in cat pca cert, and there we go. That is our ssl.ca_trusted fingerprint that we need. So go ahead, copy that, exit out of root, and let's go modify the Filebeat config file. So sudo nano filebeat.yml. Once we're here, we want to go down to output, the Elasticsearch output, and we are going to change this. I don't think it really makes a difference if we change this from localhost to the IP that we set, but just to be on the safe side, we're going to go ahead and do that. Make sure the correct port is set here, and here uncomment out the username, the password, and obviously we need to get our credentials. So we're going to go ahead and open up Elasticreds, copy password, change. Oh, did not mean to do that. There we go. Once that is done, go ahead and type in ssl_c.ca and paste in the fingerprint that we previously found. So exit out of here, go into and copy that and drop that in there. Now we want to go ahead and find Kibana. So setup.kibana. This we need to uncomment out the host. Again, I think localhost should be fine, but again, to be on the safe side, we're going to go ahead and type in the IP of our server. So 92.168.1.200 and make sure that port is set correct. Once that is done, we're going to go ahead, exit out, save the file, and enable and configure the Zeek module. Before we go ahead and enable the Zeek module, I have to make a few modifications. So what we're going to do is go ahead and we need to sort of point the filebeat.yml config file to get the Zeek logs. So we sort of want to exit out of here, go ahead to the Filebeat config file and change the path here to where our Zeek logs are stored. So if I recall correctly, it was in, just to make sure, let's go ahead and check it's actually the correct, yeah, OPT Zeek logs current, and we can see all these logs. And as I was talking earlier, the different log files, all the log files that Zeek produces here. So as we didn't see previously, we can see now files.log is there, known_services, ntp.log, oscp, etc., and weird.log, which is basically the logs that Zeek deems anomalous. So I'm going to quickly take a look at what's in here. So we can see a few active connection reuse logs and stuff like that. Pretty cool. So yeah, the directory is opt zeek logs current. So we're going to go ahead and change that to opt zeek logs current and every log file in that directory. Once that is done, what we want to do is modify the local.zeek file to sort of convert logs to the JSON format before we send those logs. And we're going to use JSON because it's sort of a uniform structure and it makes it a lot more easier to read the logs. So we're going to go ahead and type in sudo find local.zeek. And it is in opt zeek share zeek site local zeek. So I'm going to go ahead and quickly modify that. So at the very end of this file, type in at load policy tuning JSON dash logs dot Zeek. We're going to go ahead and save this, and once that is done, we need to enable the Zeek module. So what we're going to do is type in Filebeat module enable Zeek. As you can see, it's enabled Zeek. Now we're going to change to the modules.d Filebeat directory. So let's go ahead and actually, I'm not too sure where modules.d is, so let's go ahead and find that out. It is in etc Filebeat. Okay, so go into etc Filebeat, go into modules.d, and as you can see, here are all our Filebeats modules, and we can see the zeek.yml. Let's see what it currently looks like. So this is what it currently looks like, and we want to change this into a different module, and I will be pasting that in the documentation for this lab. So let's go ahead and quickly paste that in here. So yeah, let's go ahead and quickly paste that in here. Gonna sort of exit out of here, rm the current Zeek config, and now we're gonna go ahead and create our Zeek file, or sorry, Zeek config. So this is what it looks like. As you can see in the previous one, everything was set as false and there was no path, but now you can see that everything's enabled with a path to the log. So that's what we want, and we're going to go ahead and save this and exit out of it. Now, once that is all done, I'm going to go ahead and restart all of our services. So the very first thing that we want to do is go ahead and obviously restart Zeek. So to do that, go ahead and type sudo opt Zeek control, start it. It's going to stop and start Zeek again. Now we're going to go ahead and make sure our scripts are okay. So we're going to go ahead and check everything's okay. And now we're going to go ahead and also again, I don't think we need to enable the modules again since we did that previously. So we're going to go ahead and jump into Filebeat setup. Could not connect to any of the configured Elasticsearch hosts. I see why. It is because we did not specify HTTPS for Elasticsearch. So we want to go ahead and modify that real quick. Okay, I'm going to scroll down to the Elasticsearch output, and we're going to type in HTTPS. Once that is done, go ahead and type in Filebeat setup. I guess we want to sort of restart Filebeat. So we're going to type in sudo. Okay, so I figured out what the error was. So big oopsie on my part, where when we tried to get the fingerprint, we were not supposed to copy the entire certificate and paste it. What we were actually supposed to do is extract the fingerprint by running the following command. So I'm going to type in SSL x509. TC Elasticsearch, search. Now we have the fingerprint. I'm going to copy that, go in here, and we want to paste it in without the colons. So what we're going to do is delete all of this. Go ahead and paste that. And what we want to do is get rid of the colons. So there's probably a better way to do this, but just gonna have to do it manually. Okay, once that is done, we're gonna go ahead, save the modified buffer. Once that is done, we're gonna go ahead and run the setup again. There you go. It is currently loading the Kibana dashboards, and once that is done, we're gonna have to go ahead and start the Filebeat service, then check if the data is received from the Zeek module. Once that is done, we're gonna go ahead and start sudo service Filebeat start. And now we're going to check if the data is being sent. So check data successfully received from this module. And now let's explore our data. So let's click on Zeek.overview. Now we can sort of see sort of a geolocation map up top, if it would let me scroll over here. So we're seeing traffic from a bunch of places. So Oregon, LA, a lot from Central, and then on the East Coast. That is very interesting. And also some to the UK. I'm assuming that's just Ubuntu. And yeah, so over here we can see top DNS domains, and I'm seeing names of a bunch of different devices that are connected to the router. But again, this is not all the traffic that's going to the router. This is just the traffic on our interface on our desktop. So yeah, but it's pretty interesting. Now we can go ahead and take a deeper look. So if you go into Discover, here we're able to see the actual log. So let's expand this. We're able to see all the different fields here. And yeah, now this is, not very helpful in terms of, yeah, we're seeing all this data pulled in here, but we're not seeing any alerts, we're not seeing any detections, anything like that. And to configure that, we need to sort of obviously sort of fine tune our queries a little bit, and we can create dashboards based on that. So that is going to be the next part of this lab, where we are sort of going to try and make sense of all the data that's coming in here. And yeah, let's sort of jump into that. Thank you for following along so far, and I hope this was of some value to you, to sort of just how to install Elasticsearch, Filebeat, and Zeek, and sort of just help get you some visibility into your network. If you're studying for your network plus, you don't need to do all this fancy stuff. You could just run Zeek on the console and take a look at the logs itself, or the packet capture itself, and try to sort of really understand what everything means. And yeah. So now that we have verified log ingestion, and we're able to sort of see all these different events, we're able to see SSH authentication sessions, but we're not able to exactly see if those authentication events were successful or failed. So, for instance, if you wanted to see if someone's trying to brute force into our system by SSH, we're not able to exactly tell just through the logs that we're currently collecting if those SSH login attempts are successful or failed. So, to give an example, let's take a look at Zeek.SSH, and if we take a look at this, all right, we'll see a bunch of different things, right? We're able to see the source IP, so the IP where the SSH connection originated from, the destination address, which is our Ubuntu desktop server, and we're able to see the SSH client. We're able to see when the event was created, and the host OS family, things like that, and the related IPs as we previously saw. But again, cannot see if this was a successful login or a failed login. you just see this sort of log. So it's not very helpful. And while Zeek does have a brute force detection rule, it does not work. I've tried it multiple times. Maybe I need to spend some more time into exactly figuring out how that works. But there's a simpler way, and that simpler way is to use Filebeat's module, which logs it and will forward it to Kibana. So, for example, let's navigate to etc filebeat modules.d, and over here, actually before that, let's take a look at the log itself. So these events are logged in var log, and over here, it's an auth.log. So if we were to go into auth.log, or actually I'm going to use vim for this because it's easy to search, and let's type in SSH. So over here we can see, there was a bunch of successful events where I log in from a different device through SSH, and it says accepted password. We can see when it was, when the session was initiated, when it was disconnected. We're able to see the username that was used, and then we're able to see the failed login events. So here we can see there's failed password, and we can sort of create a detection rule on Kibana through Elastic query. So an Elastic rule which basically looks for a threshold. So if there are more than, let's say, 5 events or 10 failed login events, it's a good indication that someone's trying to brute force it. It will create that alert, and sort of it can either just display an alert on the dashboard or forward it to email, or if you're using sort of Slack, Teams, it can sort of generate a sort of a ping through a webhook. And there's a lot of different ways we can use just the current tool set that we have to sort of create these alerts, and we forward these logs into Filebeat. And in order to do that, just have to navigate to etc Filebeat modules.d, and over here we should have system.yml file. So what we want to do is edit that. So we want to go ahead and modify the system.yml.disable config file. What you do here is enable syslog. Sorry, we set that to true. And we want to enable authorization log. So I previously set this as true to test it out, so it's already set as true. And while we don't need syslog, it's always better to have logging in our case, just to get a better picture on what's going on in our system, and in case we ever need to filter out syslogs for just creating rules, alerts, things like that. Now, an important step here is to set the var.path, and this is important because if you do not set var.path, it will sort of overwrite the Zeek labs that we're collecting, and we'll stop seeing Zeek labs being ingested. I know this because I thought since by default it's configured to look those log paths, I wouldn't need to specify it, but since we're using Kibana and Elasticsearch, it does cause an issue when not specifying the path. So let's go ahead and set the path for syslog as var log syslog with an asterisk, and similarly for authorization logs, we're gonna set it as var.paths var log auth.log star, and we're adding the star because if you recall, when we were going through the logs manually, we saw there was also a file called auth.log.1. So I'm assuming creates different files as more and more logs are produced, and we don't want to leave out any log files. So it's always better to get all the logs for the specific log that we collect. So make sure to add the asterisk after specifying the path, and we're going to go ahead and save this modified buffer. And what we're going to do is rename it from system.yml.disable to system.yml. Once that is done, we want to go ahead and restart Filebeat. So we're going to type in systemctl start Filebeat, and let's check the status. It's up and running, so let's go ahead onto our instance and take a look at the log. Now, the exact field name that we're concerned with to see system.authentication logs is, well, system.auth. To update that, and here you can see yeah, this is just a system-related authentication session, but see some with SSH in it. So I'm going to go ahead on my other system and just try and do a failed SSH login attempt. Gone ahead and try to log in about 3 times with a failed login, and it should show up here. So see over here, we can see the process name SSHD. You can see failure, authentication failure, user was a student, and the host was from my other system trying to log in. So you can see these logs are being created, and you can go ahead and create a elastic rule to sort of alert on us whenever there's these alerts or these events happening over a certain amount of time or over a certain threshold. I think the best way to detect is to have a set threshold, maybe 10 or 15 failed login attempts. That's a good indicator of possible brute force via SSH onto that system. So now, before we dive into creating rules, let's go ahead and just create a custom dashboard. So the first thing we want to do is navigate to Kibana and come over onto the left side and click on the hamburger menu, and let's go over to Analytics and click on Dashboards. Then we're going to go ahead and click on Create Dashboards and Create Visualization. Now, over here, we're going to add the, or sort of create the charts that we sort of noted down earlier. So the top source and desktop IPs, top security alerts, failed SSH login attempts, potential port scanning, IDS alerts, geolocation of suspicious IPs, and file transfer and HTTP traffic. So to go ahead and start off with the first one, you're concerned with source.address. So we want this as our vertical axis will be count of records set by default, and horizontal axis will be top 5 values of source IP. So you can see a range of IPs, and the ones I recognize is the first 3, where this is the machine. It's basically my Mac OS laptop, where I'll be running Nmap scans from failed SSH attempts and things like that to test out our routes and detections that we're going to go ahead and create in a bit. And then this is the IP of our Ubuntu desktop, and then the third one is the IP of my PC, on which everything is running right now, and that's our default gateway. Not sure what IP this is, and this is just other. So we're going to go ahead, click on Save and Return, and then we're going to go ahead and create our top destination IPs chart. So what services are being accessed the most? While this will not exactly show us what services, but it will show us the destination address, and based on that we can do a lookup and figure out what that destination traffic is to. So let's go ahead and create visualization similar to what we did previously, and what we're concerned with is destination.address. So go ahead and add that similar to what we had previously. Now we're seeing the top 5 values destination address. So surprisingly, most of this is our Ubuntu desktop, and then this seems like the IP to which a lot of the multicast DNS queries go to. Not sure about this one. This is our Cloudflare's DNS server, and then this seems like the broadcast domain, right? Ends in 255 and has our network. And then here is other. So seems to be fine. You can go ahead, click on Save and Return. Go on to the third one, which is active security alerts. So actually, we're going to skip this one because we have not created any rules to trigger off alerts. So we're probably not going to see anything. We'll come back to this after we create our first dashboard and then our first set of alerts. So let's go ahead and create a chart for, or let's create a table for failed SSH logins. So this is sort of going to be a brute force attempt detection. Not exactly a detection, but it will show us a table and it will have a record which shows this. So go ahead, click on create visualization again, and over here we have to create a query. So event.dataset, and we want Zeek.ssh. Actually, we don't want Zeek. We need system.auth and event outcome as failure. go ahead and update that. It should, this is basically going to narrow down our search and want to break down by source address. So that's what we're gonna add. And as you can see the most amount of system auth failures, surprisingly again, from our own Ubuntu desktop, and then these two. This is my Mac laptop, which I'm using to SSH logins to. This one I'm not too sure, and then this one is our desktop again. I need to look into this one because that would not be good if someone's actively trying to SSH and failing. It means our system's actively being brute forced into, and that is not good. So go ahead, save and return, and actually change this into a table. So we see the count of records a lot of times in the last 10 days. You could also narrow that down to just the last 1 day and update that, and there we go. That makes a lot more sense in terms of the activity that's going on this desktop. This is the only IP I would expect to have failed SSH login attempts. So now for the fifth one, potential port scanning detection. So anytime someone does a nmap, any sort of active recon attempt, this would be the chart that helps us see that. So go ahead again, same step as previously, and the query for this one would be event.dataset and set this as Zeek.connection and network transport is TCP and protocol as S0 or call as rejected. Now, once we have this query, go ahead and our unique sort of count of destination port is what our metric will be, and the breakdown should be by the source address. So go ahead and add a source address, and then instead of count of records, we're gonna have it as destination port. So the basic thing that we want to look for in sort of a nmap scan is that a single source IP trying to make connections, or not even connections, but just pinging a bunch of different ports. That would be a good indicator of an nmap scan. So, or well, I shouldn't say ping, but you know, attempting to make TCP handshake requests. So we'll go ahead and save that, and we should not see any results in the last 1 day because we haven't really done much in terms of nmapping. But over the last 10 days, okay, we don't see anything there either. But once we start doing some nmap scans, we should see that populate. Go ahead and sort of minimize that a little. And now for the sixth one, we're going to do HTTP and file transfer monitoring. So let's go in, and the query that we for will be dataset as Zeek.http. And we want the breakdown by the HTTP request method, which does not seem to be unavailable for you. See HTTP request. Let's actually see and discover what the logs look like, so we have a better idea of what we want to. So let's do dataset at CP, and over here we're seeing destination geolocation, the destination IP, the event type, the source IP. That seems call. So I guess what we could take a look at is the HTTP request, the response status code. That might be, well, that wouldn't show us much. guess we can filter it by destination.as organization.name. That way, at least we know what HTTP requests are going to. So let's go back and add that as on our horizontal axis, so we can see a lot of our HTTP requests currently are going to Canonical Group Limited. I think I pronounced that correctly, but basically Ubuntu. Akamai International, Google, GCP, Akamai. So I'm assuming whatever services we're connecting might be going through probably different gateways, load balancers, things like that, which might be Akamai, or it could just be web servers hosted with Akamai. Obviously, Google, GCP, and stuff like that. So save and return that. Have that. Now, the next thing that we want to do is come over here, save the dashboard. So let's call this our SOC Analyst dashboard. Save that. Once that is done, we're going to come in here again and change this to map. But I don't know if, yeah, we need region map. And region map to route on source.geolocation. And we're going to drop this in here. That way, we can sort of work with the map here. So surprisingly, we just see, oh, okay, no, that makes sense, because why would the source be from elsewhere? Or actually, no, it should, let's do 10 days, right? See, last 10 days, there you go. We can see stuff from a bunch of different places. So go ahead and save that. Call this basic. Add this to our dashboard, SOC Analyst dashboard. Save and go to that. There we go. So, yeah, this is sort of our basic SOC Analyst dashboard. On the left side, and scroll down to security and detection rules. Now, when I have access to it right off the bat, you're going to create a private encryption key and sort of enable that in our terminal first. So in order to do that, let's go to terminal. You don't have to be in root, so if you're not in root, type in sudo nano. Actually, before we do that, let's go ahead and create the encryption key. So you want to type in OpenSSL REND -hex 16. Now, once you get this key, take note of it. So you can go ahead and also save it in a text file. So I'm going to go ahead and copy that. And now we're going to go ahead and modify the Kibana config. So I'm in Kibana.yml. Scroll all the way down. And you want to type in the following three. So expac.encrypted saved objects.encryption key. This is where you're going to paste in the encryption key that was previously generated. Since I already did this step to test it, I've already all of this typed out and I have a key set, as you can see. So I'm going to go ahead and uncomment this. Then the security session idle timeout, I would set as 30 minutes, and security session lifespan is 24 hours. Once that is done, save that, and go ahead and start Kibana. Once that is done, it should be to access the alerts part. So it's probably going to log me out here. Log in. So once we log into our Elastic instance, let's hop over to security and go into rules. You should be able to access this if you followed through with the previous steps with setting up the private encryption key. Let's click on detection rule, and we want to click on add elastic rules. So for this particular alert, we have to sort of use a pre-built security detection rule and duplicate it. The reason for this is it simplifies being able to enable aggregation of certain events, which is quite complicated when you try to do it with from scratch. For some reason, custom query language does not support aggregation-based detections, and we have to use elastic rules. And since we already have a pre-built rule, we can just duplicate that and suit it to our needs. So you see potential SIM-based port scan. This is for detecting Nmap scans. And you can see the required fields here: destination port, event action, network packets, and source IP. So we don't always see source IP, but we see source.address. So we're going to change that when we duplicate it and modify it. And we're going to get rid of event.action, as we don't always see that. And these two related integrations that are not necessary, we're going to remove those, and also cut down the index patterns to just Filebeat, since those are the only logs we're working with. So let me quickly show you the logs that we're concerned with. So in our query, we want event.dataset as Zeek.connection, connection logs, network transport as TCP, and Zeek.connection state as S0 or REJ. So these two connection states, S0 basically shows an initial connection attempt was made, but there was no reply. And I'm assuming REJ means there was an initial connection attempt made, which was rejected, or that initial, yeah, the initial attempt was rejected. So let's take a look at the log itself. So over here we can see the destination address, we can see the source address, and we can see the Zeek.connection state as S0, and that is basically a connection attempt seen with no reply. And I previously ran a nmap scan to get these logs. So once we add this rule, our customized rule, we should be able to see this alert trigger. So let's go back to rules. Now we see this pre-built rule. Come over here to the right side, click on duplicate rule. I want to duplicate the rule and its exceptions. Once that is done, we're able to sort of edit it. And if you try to edit a pre-built rule, it's not going to let you do it. It'll show you the actions part of it. Hence why we're duplicating it. So let's go ahead and get rid of the index patterns that we don't need. And for the custom query, we're going to query I previously showed you. So event.dataset as Zeek.connection, TCP, and the two connection states as S0 or REJ. Now we're going to group this by destination.address and source.address. And the threshold for this should be greater than or equal to 1, so there should be at least one record with the source and destination address. And the unique count of destination ports, let's bring it down to 25. So this basically means anytime a source address makes a bunch of connection attempts in connection state S0 or REJ over TCP, and this is in our Zeek connection logs, anytime it makes that connection to at least 25 unique ports, that's a indication of a possible nmap scan. So we're going to come down here, required fields, get rid of event.action, and we're going to change source.ip to source.address, get rid of these two related integrations, and we're going to go ahead, click on save changes. Once that is done, let's go back to our rules, and we're going to go ahead and enable our duplicated rule. Now, let's hop over to our attacker machine and run a quick nmap scan. So as you can see, I previously had a couple of nmap scans running, and I'm going to show you the exact command. So sudo nmap dash lowercase s, uppercase s, dash p, dash, and then the IP of our Ubuntu desktop. I'm going to go ahead and type in password, and there you go. Map's up and running. While this happens, let's go back over to our Elastic instance, and let's see if we're seeing those logs being generated. So we come over here and reduce time to, say, 5 minutes ago. Or actually, let's narrow that down to 1 minute ago. And we can see these logs. If you recall, what we really need is the destination address, the source address, and we need the connection state. As you can see, we have the connection state as S0, and this is the source port that it's originating from, and the destination port that the scan is currently going to. And this value, obviously, anytime there's a unique count of this over 25, the alert triggered. Now, while our nmap scan is running, see, we have about 1,657 records. So let's see if our rule actually set off, our alert was set off. So let's go click on alerts. There you go. Even before the nmap scan was complete, we see an event created with low severity where a potential SIEM-based port scan was detected. We can view the details. We can see the timestamp, so the exact time this was triggered. The index was Filebeat, and I guess the predefined rule has a full description of this rule. So this rule identifies a potential SIEM-based port scan A SYN port scan is a technique employed by attackers to scan a target network for open ports by sending SYN packets to multiple ports and observing the response. Attackers use this method to identify potential entry points or services that may be vulnerable to exploitation, allowing them to launch targeted attacks or gain unauthorized access to the system or network, compromising its security and potentially leading to data breaches or further malicious activities. So, it's a good description, and this investigation guide was created using Gen AI technology and has been reviewed. Nice. And if you come down here, it'll actually show you the MITRE attack framework tactics. So it has, obviously it's a recon, active scanning, scanning IP blocks tactic, which is pretty cool. It already has a MITRE attack map to it. And yeah, so can we see the source IP here in this alert? I wanted to drill down on this. Let's see. Actions. Okay, yeah, so we're able to see in overview highlighted field, you can see the source IP here and the destination IP. So to create a rule that detects potential force, what we want to do, potential brute force through SSH, what we want to do is create a new rule, then, add elastic rules and search for potential internal SSH brute force. Go ahead and duplicate that, and once you do that, you want to get rid of the original EQL query, and then obviously trim down your index just to Filebeat, type in sequence by source address with max span of 2 minutes. So you'll look for login attempts by specific IP within 2 minutes. Type in brackets, authentication where event action equals to SSH login and system auth to event equals to fail, and have this repeated around 5 times. So this is basically going to look for 5 failed login events and then the alert. Required field should be event.action, system.auth.ssh event, source address, and related users. Go ahead and save that alert. On my attacker machine, I did try to do a bunch of failed SSH logins and did create the alerts, so we know it's working. I'm gonna go. So thank you for watching this lab and following along so far. This is what our dashboard looks like after a couple of days of just capturing traffic. And yeah, so I hope this lab was of some value for you, and obviously there will be documentation for each and every step. If you have any questions or doubts, please feel free to reach out, and I will do my best to address your doubts and queries. Thank you so much, and in the next series of this lab, we will be sort of coming up with a scenario and sort of trying to simulate incident response, and will be pretty cool. So, yeah.